Today is December 22nd, 2022. This is my 169th episode for C++ 17 2023 9 OpenGL TBB Balkan. We are learning implicitly defined functions, derivatives of higher order 5, second order derivative 2. We will complete second order derivative for implicitly defined functions. To follow my current session, you probably need to watch episode 168, episode 167, especially understanding episode 167 is very important. Please click this link. From our previous episode 168, higher order derivative for second order derivatives 1, show more, download current video source code, show in folder, unzip it, rename 169, copy the folder path, paste it in your working directory, open up Visual Studio Code. CPP 17 2023 from folder 169 open holiness.hpp newton.cpp Ctrl V. I will arrange side by side. If you haven't watched my previous video episode 168, you may have difficulties following my current session. In this episode, we will be using CPT for Stellion. For Stellion is a compile time loop. It internally uses CPT sequence of type long. Once again, for Stellion is a compile time loop. For Stellion internally uses CPT sequence type long. CPT sequence is defined long ins, such as template long ins. So I will change from int to long. Copy, paste. Copy this, paste. Solve for 0. Copy, paste. 2, 3, 4, 5, 6, 7, 8, 9. Paste dependent 0, dependent variable 0. Copy, paste. Copy, paste. This is independent variable. Copy, paste. I will remove some space. Open up Intel compiler. CD 168 Newton ICPX SED C++20 F no sigle Newton.cpp or I.exe, hit enter. Okay, it should build and run. Now Microsoft compiler CD 169 Newton CLEHSC SED C++20 Newton. It should be lowercase .cpp fe m.exe, hit enter. CLSM. Now clang compiler CD 169 Newton clang SED C++20 Newton.cpp ltb12 or c.exe, hit enter. CLSC. Now GNU compiler CLSG. All compiler should build and run. Now please understand that in this file newton.cpp control end, we created this function in our previous episode. So if you haven't watched it, my previous episode, episode 168, you may have difficulties following my current session. Copy this function up to this point. Copy, paste it. Scroll up. I will rename the function second order derivative theory. Basic. Copy this function name. Control end. Paste it here. I will disable it. Now, in this file, control end. Here, we will create a function template long var index. This is independent variable, or I can say in the index long dep index, dependent variable index. Type name func type cpt arithmetic c arg types or implicit derivative second order func type func arg types args open curly brace. We need to use some namespace. Copy this, paste it here. I will remove this. I will arrange like this. We don't need namespace holiness because we are inside of namespace holiness. We create auto partial. We capture all by L-value reference. Auto comment semicolon return CNA partial derivative. We pass command, then F, then ARGs. We created simple lambda. I captured by reference because this lambda is not used outside this function. If we return this lambda outside of this function, we have to use capture by value. But we are using this lambda only inside of this function. Now I will copy some source code from here. up to this point. Copy, paste it here. In step 1, we call this function partial, like this. We cannot use this because our independent variable, dependent variable will be changed. So dx d1 amounts to CPT sequence. Independent variable index, we differentiate once. So 1, it should be object. I will say auto and context per semicolon. We don't need to pass these things because ARGs will be passed. All we need to pass is command. Now step 2, context per auto dy, it should be, this is dependent index. Please be careful. Independent index is defined to be long. It should be of same type, so it should be long. Please be careful. Also, dependent index is defined to be long. It should be long. We can delete this part. In the same manner, copy, paste. This is dx2, then independent index 2, second order derivative. In this case, I will copy this. We don't need to copy. Context per, this is defined here. This is defined here. Then partial, I will remove this. It should also be fixed. Partial, we can remove this part. In this case, copy this, paste. This is dy2. This is dependent variable dp index. It should be partial. It should be removed. Now we can return our computation. With this, we can simplify this part. We can now delete this part. Instead, we can use this function, implicit derivative, second order, paste it here. We pass, for example, we defined independent variable x, then dependent variable y. We pass function f and xy, f and xy. I will put line break here and fix our code like this. So we are calling this function here. Now we try with the Intel compiler. CLSI, this is algebraic solution. This is numerical solution. Our new implementation here, or this implementation works correctly. We can try with the Microsoft compiler. There's some problem. Partial derivative, no matching overloaded found. Here, I made mistake. This is not partial. This is fixed. Also fixed. We try again. Why it is causing trouble? 220. Partial is not a member of Holiness CNA. I made very silly mistake. We build again. Now it is built successfully. Microsoft compiler now works. With the GNU compiler, CLSG, with the Clang compiler, Clang, CLSC, every compiler works. Now let's move on. Please understand, we created this function in our previous episode, episode 168. I will change it to long. Also long. Now we will copy first order generalized up to this point. Copy, Control, N. We will paste it here. Scroll up. We will rename second order generalized. This is our function arguments. In this function arguments, independent variables plus dependent variable. Dependent variable is 1. Now here, copy, paste. This is independent variable count. From this, we minus 1. This is dependent variables count. Now scroll down. Everything is the same. But in this part, we have to fix like this. Return CPT for stellium. We pass independent count. We defined this constant here, independent variables count. Now we create another lambda, or second derivative. We capture by reference, or independent index. We are creating a lambda. We use CPT sequence. Then we need to consume this argument. We have to expand, curly brace, semicolon. We pass this lambda to our stellium. Now here we return SED array. This array block I will indent a little bit. We call this function implicit derivative, second order. Here, by passing independent index, then dependent index. Okay, I will put carriage return. We pass function f. Then these values like this. Please understand, this is one function call. Independent variable index is a parameter pack. The pack independent index parameter pack should be expanded. Basically, we are computing dz over dx, dz over dy, where z is dependent variable, x and y are independent variable or independent variables. So dpidx represent dependent variable z. In the idx, I say represents independent variables x, y, etc. I will fold it up. This forms loop. For folium is compile time loop. Iterates over independent count or number of independent variables. I hope you understand this configuration. Now scroll down. We are calling diff by passing coordinates. This diff is defined here. We just defined. Now everything is ready. Basically, I used first order derivative to implement second order derivative. We implemented first order derivative in this video. So if you don't understand how we implemented this function completely, you probably cannot understand my current video. Now scroll up. In our previous episode, we created second order derivative theory. Now we implemented this function in episode 168. Copy up to this point, copy, scroll down, paste it here. Now test second order derivative theory final. Copy this function name, Ctrl N. We pasted it here. We will disable it. Now scroll up. In this function, this is numerical solution part. We will give carriage return here, then underscore second order derivatives. Now copy this, auto paste. We now can call this function that we just defined here. Copy, paste. We pass solve for y. Dependent variable is dep y. I will put carriage return. Then we pass in this case, split count this one here, then everything is ready. We don't need these. I fixed like this. So we actually don't need extended Newton here, but I called it for algebraic solution for second order derivative. All these parts are just for testing purpose. We can solve second order derivative just calling implicit derivative second order generalized. With this, we will try with the Intel compiler. CLSI. Something wrong. This is final. This is not final. We rebuild. I'm very sorry. We are in the wrong folder. CD 169 Newton. I'm in the wrong folder. We rebuild. CLSI. So our numerical derivative matches algebraic solution. I will give a line break here, like this. Now let's try with the Microsoft compiler. CLSM. Microsoft compiler also works perfectly. Now GNU compiler. CLSG. Clang compiler. Clang. CLSC. Every compiler works. Now we can solve problems with S, T, X, Y, Z. For example, implicit function with 5 variables. We can evaluate second order derivative.